Okay, so for number 13, we're trying to determine which quadrant that angle A would land in. So when it starts telling you about sine being positive and then the product of them being negative, what we need to remember is our diagram or our chart that helps us remember where each one of them are positive. That's what this is talking about here. So in quadrant 1, they're all positive. Only sine and its reciprocal are positive in quadrant 2. Tan and cosine and secant. So if sine and cosecant are positive in quadrant 2, it's implying that the rest of them are negative. All right. So what we do is process of elimination. So this first constraint here is telling me that angle A must be in a quadrant where sine is greater than 0 or positive, which means that it can't be here or here. It could either be in quadrant 1 or in quadrant 2, and that's where sine is positive. So now we know sine is positive. All right, so there's no way that this can be negative here. It just told me it was positive. So if we're going to multiply a positive times cosine and get a negative, then cosine must be negative. So out of the two that are left, I have to find the quadrant where sine's positive and cosine's negative, and that would have to be quadrant 2. Can't be here because cosine would be positive there. So that's how you figure that one out, sort of process of elimination. Okay. For number 15, it's giving me some information about angle A. It's telling me the quadrant. It's telling me cosine. So before I even read any further, I'm going to go ahead and make my diagram in quadrant 1 and label that if I'm at the origin and I go to the right is positive, up is positive, hypotenuse is always positive. So angle A would be right there. The reference angle is always that angle at the origin there, the gap between the terminal side of your angle and the x-axis. Okay, so cosine is adjacent over hypotenuse. So I'm going to fill in those sides based on where angle A is. Adjacent would be right here. That's 4. Hypotenuse is 5. Hopefully you recognize this as a Pythagorean triple. As long as your hypotenuse is 5, then this would be a 3, 4, 5. Okay, so once I have all the sides labeled, now I'm going to see what they want me to answer. So it wants me to find the product of sine of A times tan of A. Well, now I can use my diagram to figure those out. So sine is opposite over hypotenuse, tan is opposite over adjacent. So opposite over hypotenuse, and we're going to multiply that by opposite over adjacent. And basically you just multiply across 9 over 20. Okay. All right, so similar here. They're giving me some information about angle theta now. It's telling me the second quadrant, and it's giving me tangent. So let me set up a diagram. Second quadrant, making my reference angle always the gap between the terminal side, right? So really the angle rotates and lands there, but we're going to use this reference angle that's in between the terminal side and the x-axis right there. Before I start putting in the sides for tangent, you got to figure out, okay, going to the left from the origin is negative, up is positive, hypotenuse is always positive. I would get that labeled first, especially in this situation, because it puts the negative in front there. So it's hard to tell at this point if the 2 is going to be negative or the 3. So whenever you have a negative fraction, it could either be in the numerator or it could be in the denominator. So by putting those positive and negatives on my diagram first, I can tell that when I'm going to label my opposite over adjacent, I can tell that it's actually the adjacent side that's negative, not the opposite. Okay, so 2 and 3 as your legs is not a Pythagorean triple, so let's put those into the Pythagorean theorem to find our hypotenuse. So even though 3 is negative, you're going to square it, right? Which is why your hypotenuse is always positive. And we get a hypotenuse of rad 13. Okay. So now it wants the cosine of theta. So we don't have to use the obtuse angle. We're going to use the reference angle to represent theta, and it's going to be adjacent over hypotenuse. And again, multiple choice is going to have it rationalized. So you got to rationalize that denominator, and you're going to get negative rad 13 over 13. If you're completely lost on a question like this, which I hope you're not, but if you do understand where there are positive and negatives, you could eliminate some choices this way as well. So if we know we're in the second quadrant and we're finding the value of cosine, we should know that cosine is going to be negative. So at least you should be able to eliminate those options that are positive, right? Because only sine is positive here, cosine's negative. So that's just a little added check there at the end. Okay. So presented in a different way, this is telling me, without coming out and saying it, what quadrant I'm in. So if you were going to graph the point, negative 4, 1, you would go to the left 4. So I'm going to label that minus 4, and you would go up 1, putting me in quadrant 2. So there's some angle that rotated around, landed in quadrant 2, and then again, we're going to use the reference angle right there. All right. So we need to find cosecant, which is going to be I need my hypotenuse. So Pythagorean theorem again. All right, so our hypotenuse, always positive, right? Opposite's positive also. Rad 17. So at this point, I hope you have it memorized that cosecant and sine are reciprocals of each other. So if sine of theta is opposite over hypotenuse, then cosecant of theta is going to be hypotenuse over opposite. So the hypotenuse is rad 17, and the opposite is 1. So this one would be rad 17. Okay. All right, so for questions like these, you got to analyze the type of angle you have to see what diagram you should make. So let's start with 3 pi over 2. Now, I gave you guys some options for this. 3 pi over 2 is not part of our special rights. You can do one of two things. You can create your unit circle, right, where 3 pi over 2 would be down here. The thing with the unit circle, well, there's two things. First of all, the radius is always 1, so I know that this point right here would be 0, negative 1. The other thing with the unit circle is that every point on the unit circle, cosine is the x value, sine is the y value. So if I want the sine of 3 pi over 2, it's going to be negative 1. So if I rewrite this, sine of 3 pi over 2 minus cosine of pi over 3, in for this whole thing, that whole thing equals negative 1. Now I'm going to figure out the cosine of pi over 3. Oh, hold on. So let me give you the second option for this. The other option for a quadrantal angle is if you're looking for the sine at a quadrantal angle, you could also have memorized at this point the sine graph. So sine fluctuates between negative 1 and 1. You would label your quadrantal angles like the unit circle unraveled. And you have to remember that sine starts at the midline, goes to the max, back to the minimum, and then back to the midline. So this is just another way to see that at 3 pi over 2, sine is negative 1. All right. Now at pi over 3, this is a special right. So for this one, it's a different diagram. So if you have these diagrams in front of you during the test, that might be a good thing because then you could just kind of look at them and fill in the answers from there. Across from pi over 6 is 1. Across from pi over 3 is rad 3. And then, of course, across from the hypotenuse is 2. So cosine of pi over 3, that means my reference angle's over here, adjacent over hypotenuse. So negative 1 minus 1/2 is negative 1 1/2. Okay, same idea for this. So what we're going to do is we're going to fill in what tan of pi over 4 is and add that to sine of pi over 2. So for tan of pi over 4, you're going to look to your special right, and tangent is, if I use that one as my reference angle, opposite over adjacent. 1 over 1 is just 1. I'll put it there so you can see it. All right, so right now we have 2 times 1. And now pi over 2, that's a quadrantal angle. So I'm going to go back a screen here, sine of pi over 2. So you could either use the unit circle at pi over 2, which is 0, 1. And sine would be the y value there. So sine of pi over 2 is 1. Or you can look at your sine graph again at pi over 2 is 1. Whoops. So 2 times 1 plus 1 is 3. Okay. All right, last question. So find the reference angle. The reference angle is always the gap between the terminal side and the x-axis. So the first thing I want to do is graph 11 pi over 6. So I'm going to start here at 0. Instead of pi, I'm going to use the denominator to help me drive how I'm going to represent pi, which is 6 pi over 6. Halfway there is 3 pi over 6. So every 90-degree turn is 3 pi over 6, making this 9 pi over 6. Add another 3 pi over 6 to that, and you get 12 pi over 6. So we're making, where this is a positive 11 pi over 6. So I'm rotating around and landing in quadrant 4. So if this is 11 pi over 6, the reference angle is going to be the gap right there. So 11 pi over 6, I rotated around. I didn't quite make it to 12 pi over 6. So you just have to figure out how much more would I have to rotate to get from 11 pi over 6 to 12 pi over 6. It's pi over 6. By the way, reference angle is always positive. So these two are out. And we just figured out that it's pi over 6. Okay. So that's the odds for you. We're going to have, you should have a little extra time now to start working on the evens, and the evens is your homework for tonight. And then I'll make another video tomorrow for the evens. All right, guys. Talk to you later.